The generator crankshaft in front of us has become too old over time. After working continuously for 3 days, it finally couldn't bear the pressure and snapped into 2 pieces. Since the generator itself is an antique, it's practically impossible to find new parts for it. So, the owner brought it to this professional repair shop to ask the mechanic if it could be fixed. After inspecting it, the mechanic said the problem wasn't too big. With just 2,000 rupees, it could be restored by nightfall. To ensure that the repaired crankshaft has no dimensional discrepancies, the mechanic first needs to measure and record the exact length of the entire crankshaft. Once the measurement is complete, because the crankshaft has an irregular key shape, this makes it rotate unevenly during machining. As they say, as long as your mindset is solid, solutions are always more abundant than difficulties. After welding, the mechanic secures the steel rod and crankshaft onto the lathe's chuck plate and uses a lathe tool to smooth out the broken surface. For this type of shaft alignment, the mechanic must ensure that both sections are perfectly aligned and, with his experience, cuts away a projection used for the joining process. Once the outer diameter of the projection reaches the joining standard, to strengthen the bond between the 2 sections, the mechanic must also lathe away the external threads on the projection. The mechanic works skillfully, quickly threading the projection on the shaft. Because the lathing process shortened the crankshaft slightly, to compensate for the lost length, the mechanic plans to use the round steel rod as the joining material. After removing the round steel rod, he processes it according to the data recorded earlier. Since the steel rod is slightly larger than the hole diameter, it needs to be trimmed down with a threading tool to fit. After adjusting the outer diameter to the joining standard, as the crankshaft already has a projection reserved for the joint, the steel rod must be drilled with a hole that matches the projection's diameter. However, the drilled hole still has minor discrepancies, so the mechanic uses a reaming tool to adjust the inner diameter until it perfectly fits the projection. Once the hole drilling is complete, the mechanic also needs to thread the inside of the hole. This not only increases the joint's strength, but also ensures the crankshaft remains concentric after joining. Once the threading is done, the required section of the round steel rod can be cut. During this process, the mechanic also works on the other half of the crankshaft, preparing a matching step for the joint. With the steel rod cut, the next step is to process the other section of the crankshaft. To ensure the crankshaft's concentricity when fixed in place, the mechanic switches from a 3-jaw chuck to a 4-jaw chuck to adjust the crankshaft's center point. Only when the shaft is perfectly centered can the ends be laid flat. The key to joining the sections lies in precise drilling, allowing both ends to fit tightly together. Using the projection and the round steel rod as a machining standard, the mechanic expands the hole cup with a reaming tool. After several rounds of accurate measurement and adjustments, the crankshaft meets the required standard. Once all the connecting components are machined, the mechanic precisely aligns and joins the 3 shaft sections into one complete crankshaft. After the assembly is finished, the mechanic rotates the lathe to check if the crankshaft is concentric. Once everything meets the requirements, welding can proceed. To ensure weld quality, the mechanic stops after each weld layer to tap off the surface slag, preventing slag from contaminating the weld. After the welding is completed, the mechanic carefully grinds down the 2 welded joints, ensuring the surface is smooth and perfectly matches the original factory dimensions. To ensure the crankshaft meets the usage standards, the mechanic reinstalls the connecting rods. Only after this test can he guarantee the newly repaired crankshaft will work flawlessly. But the repair isn't finished yet. The mechanic still needs to remove the temporary steel rod used for securing the crankshaft. Using an angle grinder, he cuts the welded steel rod, then smooths the welds with a grinding wheel. Finally, bearings are reinstalled onto the crankshaft. At this point, the crankshaft repair is officially complete. What do you think of the mechanic's craftsmanship? If you had to give a rating out of 10, how many points would you give?